What might be the world's most powerful creature? Is it the lion? The bear? Perhaps the elephant? Or could it even be the cockroach, known for its astonishing resilience, seemingly poised to survive the apocalypse? Before we embark on this intriguing inquiry, let us first explore a more intuitive question. Why are Russians typically taller, while Indonesians tend to be shorter? To unravel this, we shall consider another classic question, a well-known conundrum in the realm of physics. Explain, from a physics perspective, why the giants and dwarfs in Gulliver's travels could not realistically exist. You may wonder why this would be considered a physics question. Isn't it more suited to biology? While it indeed straddles both domains, fundamentally, it is rooted in physics. Physics aims to explore the truths that govern all phenomena. We can approach this problem from two primary angles. These are merely my interpretations. Naturally, one could devise alternative answers. Just as there exist over 400 proofs for the Pythagorean theorem, multiple explanations can arise. Nonetheless, I propose two principal answers. The first concerns the concept of heat. Heat is paramount for the survival of life. Humans cannot endure temperatures exceeding 46 degrees C, leading me to suggest that within the next decade, humankind may find itself confined to climate-controlled environments. Now, how does the human body dissipate heat? Through the skin, of course. A larger skin surface area facilitates more efficient heat dissipation. But how is skin surface area determined? In essence, it is proportional to the square of height. Thus, if one were to double or triple their height, the capacity for heat dissipation increases with the square of length. However, we must also consider the volume of the body, which governs internal heat retention and is proportional to the cube of height. Consequently, as height increases, the ability to release heat diminishes, making larger bodies more prone to overheating while simultaneously better insulated against cold. Therefore, the giants and dwarfs depicted in Gulliver's travels are not physically feasible. At a uniform temperature, giants would overheat and perish, while dwarfs would likely succumb to the cold. This line of reasoning also answers our earlier inquiry. To survive the harsh climates of Russia, larger body sizes are advantageous for heat retention. Conversely, in the warm climates of Indonesia, smaller physiques are favored to enhance heat dissipation. Now, one might ponder, what of the enormous insects found in tropical regions? Is this not contradictory? The explanation is straightforward. These insects lack traditional skin. Instead, they are encased in armor-like exoskeletons, which do not facilitate heat dissipation through skin. Moreover, the trait of heat retention in larger bodies is characteristic of warm-blooded animals, while cold-blooded creatures like lizards operate under an entirely different mechanism. The second reason relates to weight. Weight is defined as density multiplied by volume, meaning that unless the materials composing a creature are drastically varied, weight is proportionate to the cube of length. Comparing muscular bodybuilders to severely obese individuals, we find that density changes insignificantly relative to changes in volume, allowing us to approximate weight as a function of the cube of height. Now, let us consider how a body supports its weight. Similar to how structural beams support buildings, bones bear the weight of our bodies. The ability to withstand weight depends on the density of bone material and the cross-sectional area of the bones, which increases with the square of length. Given that weight escalates with the cube of length, the pressure exerted on bones rises sharply as size increases, potentially leading to structural failure. Returning to the context of Gulliver's travels, if Gulliver were a giant, the bones required to support such mass would be implausibly large. Even assuming his bones were made of titanium, it is unlikely they could bear the weight required at such a size. Without such extraordinary strength, Gulliver would likely suffer severe ailments, such as disc problems or scoliosis, rendering him immobile. I do apologize for my continued penchant for humor today. Thus, Gulliver could not exist, as his joints would not withstand the mechanical demands of his size. What occurs if a creature becomes excessively small? While it may easily manage its weight, this results in inefficiencies. Inefficient species tend to face extinction. Consider the ant. It possesses an exoskeleton that mitigates inefficiencies by supporting its structure externally. This adaptation is sufficient for its size, rendering an internal skeleton unnecessary. Now let us return to our original query. Who is truly the strongest? Our experiences may suggest that larger creatures possess greater strength, pointing to the elephant as a leading contender. However, we must also consider the cockroach. The African elephant can weigh between 3 and 8 tons, equivalent to 100 adult humans, and may stand over 3 meters tall. A lion, while capable of tearing apart a human, poses little threat to an elephant, which can easily trample a hippopotamus as if it were merely a house cat. Strength seems to rest firmly with the elephant. Yet, concluding here would not elevate this discourse to the level of a scientific analysis. This channel encompasses various topics, including economics, my own academic focus. Earlier, I had predicted the viability of investing in Nvidia and TSMC stocks. Did anyone take that advice? Regrettably, I was unable to invest, but those who did may have realized significant gains. Feel free to request stock predictions in the future, though I must note that they may not result in high view counts. Returning to our intriguing cockroach, this creature is remarkable in its own right. If a cockroach were scaled to human size, it could traverse 100 meters in under a second, 10 times faster than Usain Bolt. Fleas can leap up to 100 times their height. Imagine a leap of 200 meters. Such a cockroach could clear buildings in New York City. Can physics elucidate this phenomenon? Certainly. In animals, strength derives from muscle, which scales with the square of body length. By this stage, the purpose of my earlier discussions should be clear. Muscle strength is proportional to the square of length, while weight is proportional to the cube. Hence, as size increases, the efficiency of strength declines. This scaling effect allows smaller creatures to demonstrate remarkable capabilities relative to their size. Let us reflect once more on the capabilities of our insect friends. When we consider scaling these creatures to human size, the flea might leap 200 meters, while the cockroach could cover 100 meters in a second. However, this assumes a hypothetical scenario of if they were human-sized. In reality, a cockroach runs at a speed of about 20 centimeters per second, while a flea can jump only about 30 centimeters. Thus, the impressive feats attributed to them are largely illusory, a result of scaling misunderstandings. Indeed, we can leap around 30 centimeters as well. In a race against a cockroach, we would likely prevail. This phenomenon arises from the relationship between strength, growing with the square of length, and weight, which increases with the cube of length. As size increases, the absolute strength of an organism grows, but the relative capacity for movement declines due to the faster increase in volume. It should not be surprising that a flea can jump 100 times its height. Here's a thought that might surprise you. Across various species, jumping ability remains relatively similar. Certainly, my own jumping ability pales in comparison to that of Usain Bolt, yet the difference is not as vast as one might think. If you find yourself discussing the extraordinary abilities of other creatures, consider sharing this insight. In fact, the jumping abilities of all organisms are comparable due to the square-cube law. Your listeners may regard you with newfound admiration. If you choose not to subscribe and like this channel, you might just find yourself reincarnated as a cockroach in your next life. See you!